Well, I don't know what I expected to happen to my fingers doing that. Hello Internet, my name is Quinn and this is Blondihacks. It's a great day in the shop today. We're going to make first chips on the PM1 model steam engine. Let's go. Now last time we talked about the base casting and some of the different operations that we're going to need to do on it, so I think we are ready to get started. And machining the bottom is actually the obvious first step because that'll give us the opportunity to fixture this guy any way that we need to. Now I just want to take a quick second to recognize the old timers in model engineering. I've been reading a lot of these old books and it's really interesting how the old timers would have done this. They would have bolted this thing to the faceplate on their lathe and spun it around like that and faced the bottom. And it would have been a pretty terrifying setup. But if you've ever had thoughts that you absolutely have to have a vertical mill because there are things that you think you can't do on your lathe, go read those old model engineering books and it will absolutely change your mind about what's possible on the lathe. That said, I'm going to do it on the mill because I have one and it will be easier. Step one is to get rid of the vise. Because we're mostly working with odd-shaped castings and things on this project, the vise won't be a whole lot of use, and that's actually part of why I'm interested in this project. It's going to give me a chance to really stretch my wings on table fixturing. So I'm going to set up to machine the bottom of this casting. So my thought is to suspend it on a 1-2-3 block, and for that I'm going to make some 1/4-20 studs that will allow me to bolt through that whole assembly. So I've got some 1/4-20 all thread here, and I cut some pieces, and then a quick face and chamfer on the lathe makes some very nice little studs. And I don't have a 1/4-20 T-nuts, so I'm just using a nut and a washer on the underside, and this works okay. You know, it's not ideal, but it is possible to get the nuts to tighten from above without the bottom side loosening if you're careful about it. If I had to do this a lot, I would certainly go just make some 1/4-20 T-nuts, but this will get the job done here. And I'm going to put a little machinist jack on the high side there for a little extra support. Because the entire casting is rough at this point, it doesn't really matter what we reference. We're really just trying to kind of average the error in the casting. So we just want to make sure that we set up such that we don't have any super crazy high spots or super crazy low spots. And I found this little piece of scrap that fits perfectly on those little shoulders, so that'll allow me to clamp the casting down to the top of the machinist jack while still leaving the base area that we need to machine completely clear. Now I'm using an indicator to map out the surface. I want to know how much variation there is, what the highest spot is, what the low spot is, where we should touch off, and also this will tell me if the casting is completely out of whack as far as how we have it fixtured. We're within 5 thou all the way around except for one corner there that's like 20 thou low, so that tells me that A, the setup is good, our casting is as level as one can reasonably expect for a casting, and it also says that the casting is actually quite good. And we know that this corner back here is the high spot, so that's where I'll touch off, and I run all the way around until we are cleaned up all the way. Most of the casting only took about 10 thou to clean up. This one corner here needed about another 20 thou to clean up, and I didn't want to go any deeper than that because some of the flanges and things were starting to get a little bit thin, but that is actually an important support area there under the bearing cap also, so I didn't want to leave a big inclusion there. So I did my best to split the difference without getting too thin anywhere. Cast iron is pretty messy stuff. I'm developing a serious case of model engineer fingers, and I'm also cleaning up the machine after each operation because this cast iron dust is itself a little bit gritty, and it's also probably got sand in it from the sand casting process, so you don't want that lingering on the machine. Let's see how flat I actually got it because that'll matter for later setups. And yeah, actually I've got 0 rock across one corner and just a very hint of a rock across the other, so that might even be grit under it on the table or something. So I'm really happy with that. It seems like we got it flat. So now we can use that freshly machined surface to clamp it down right side up, and we can set up to machine the crosshead slides. That's the really important reference surface that's going to set the axis of the engine and the location of the crankshaft. Once again, I'm mapping out these surfaces with an indicator just to see where the casting is landing, and actually we're within about 3 thou everywhere, which basically says that the casting is quite consistent. It certainly should be level because we've machined the bottom, and the bottom and top surfaces of the casting should have been relatively parallel, and they are. So this is good news. It seems like our setup is sound. That sub 5 thou variation is extra good news because, as I explained in the previous video, we really want to remove as little material from these crosshead slides as we can, because if I get these slides too low, then it's going to push the center axis of the crankshaft down too low, and it's going to no longer land in the center of those bearing lands. So I'm Now just cleaning up these two surfaces here, removing as little as I can. I think it only took about 5 or maybe 8 thou to clean these up, so that's great news. It's really, so far, seems to be quite a nice casting. I'm quite happy with that surface finish. I may even polish it a little bit because there is going to be a sliding mechanism on there, and, well, I don't know what I expected to happen to my fingers doing that. Okay, moment of truth time. Let's check the height of the crankshaft using the same 120 gauge block that we did last time as our test. And it looks like we are going to land in the middle of that bearing cap, so that's great news. Okay, so in principle, we've established now the height of the center axis of the engine, that all critical axis that's running through all of the running gear and the cylinder. So we know it should be 125 referenced up from these surfaces. So now the question is, where do we get the horizontal position of that axis? Well, over on the drawings, the center axis is referenced horizontally really from 2 places, from the sides of the bearing caps and also from the sides of the crosshead slides. You see these little F symbols here. Those are referring to surfaces that go down into the page and indicating that those should be machined, finished, for F for finished. Now we're effectively creating this datum, this axis, from whatever we machine. So all we really need to do is get it aesthetically centered, and then we can reference everything else from that. So I need to machine these 2 surfaces in here and the sides of the crosshead slides. And what I can do is just machine them evenly as best I can so that, you know, the top surfaces come out roughly the same width, and then that becomes my center line from which I can reference the other of these pairs of surfaces. So I took some measurements of the rough casting here to see how much material we have to remove. And we have about 140 thou to take out of this area here, this slot. And we have about 100 thou to take out of this area. So there's less material back here. So I think what I'm going to do is machine these surfaces first. And I'm just going to machine, you know, clean up both surfaces and then try to get them so that the bearing lands are, you know, roughly the same length. It doesn't have to be precise because the outsides are remaining rough. And again, this is essentially aesthetic because once this is machined, as long as we are centered sufficiently that we are within the casting area for all the other features that need to be machined, then we've done our job. So I'm going to machine as little as I can off of here to get this space in here to be the necessary width according to the drawing, while keeping these casting areas kind of the same size, as close to the same size as possible. And once that's done, I can edge find on those surfaces and get a real proper center line for the first time on this engine. And from there, I can do everything else. So I can machine these inside surfaces. I can, you know, eventually make the hole down here for the piston rod. I can do everything else once I've got those 2 surfaces defining the horizontal position of the axis, and I've got these surfaces defining the vertical. Before we machine the insides of those bearing lands, I need to make sure my casting is as straight as I can get it on the x-axis. So I'm indicating using the rough casting on the crosshead slides because it's the longest straight surface that we have on the casting. And obviously it's jumping around a lot because it's a casting, but we can at least get a rough idea that, you know, we're within 5/1000ths here of being straight, and the variation is kind of in the same place on both sides. So we'll just have to take that as good. And I'm using a very long reach 1/4 inch end mill here to side mill these caps. Luckily we don't have too far to go. I'm doing spring passes here as well on each pass because there is a lot of stick out there on that end mill. It's not very rigid, so in order to make sure I don't get any taper or miss the dimension, a spring pass is really helpful. Calipers are useful for a rough guess of where we're at, but when we really need to know, I've got just the tool for that. Adjustable parallels. These are a recent donation to the channel. I had a viewer who took pity on me seeing me trying to use gauge blocks and end mills and other things to measure gaps. Let's see how we did here. We're aiming for 1" 256 because this is an 8-bit engine, and we came in at 1" 255.5. You know what? I'm gonna take that. Here's a closer look at the machined area that we ended up with, and you can see how there's kind of a scallop at one end and a flat spot on the other, and this matches where the drawing kind of indicated the area that needed to be machined. And you can see that I have kind of a double scallop there at one end. I had some mishaps when I was trying to read the DRO and trying to set the endpoint, so I ended up with a little bit of character there. But now we are ready to deburr and do our edge finding on those surfaces, which is going to give us, for once and for reals, the center line of the engine. It's very exciting. Now we can machine the sides of the crosshead slides, and I'm just checking to make sure I'm going to have clearance here. It's going to be close on that clamp, but we've got it done, I think. And I'm going to once again use this long reach end mill. It's not my preference because of the lack of rigidity, but it's really the only way to get in there. Even without that clamp there, regular end mills just won't reach down in there. So I'm taking light passes and spring passes once again. Now the key to this operation is I want the machined surfaces to end up equidistant in the y-axis from the center axis of the engine. So I'm using the incremental scale on the DRO to track one surface and the absolute scale to track the other. So the 0 is one end, the end that's kind of a blind end, and then the other end where the end mill can run off, I don't have to track. And then the y-axis is then just positive, the same number on one side, and negative, the same number on the other side. So I'm moving back and forth the same amounts on either side of 0 and machining about 10 thou at a time and sneaking up on the final width that we need in that slot. And when I think I'm close, I can go ahead and deburr this and once again get in there with the adjustable parallels and measure that gap in there. We're aiming for 590 and we landed at 589 and a half. That half thou seems to be the theme of the day. I should just move my mill over half a thou. Now, as I was doing that, I was kind of incidentally machining the top of that web in there, but that web is actually supposed to have a specific depth. So I come in here with my depth mic and see where we're at. It's pretty deep, so I was not in any danger of going too deep milling the sides of the crosshead slides. So we've got quite a ways to go there. So I come back in and I still have the zeros for the two slide surfaces set with my absolute and incremental y-axis zeros. So I can easily come back in and go to those zeros and then mill back and forth, working my way down on that little web. And amusingly, the web was a little bit wider than twice this end mill, so I had a little nub in there, which was extremely satisfying to mill away. That depth needs to be 375, and we came in at yeah, you guessed it, 374 and a half. So apparently I also need to move my mill up half a thou. And deburr, 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 and move on to the next step. So we have this interesting little trench that we need to make at the end of the crosshead slide, and we need to face the end there where the gland nut for the piston rod is going to be. So that little gap there needs to be 250 wide. So we've got quite a bit to remove there from that area of the casting. Now my long reach end mill would be tempting here again, but the gap that I need is 1/4 inch wide, which is the same as my end mill, and that would be too heavy of a cut to do in one pass. So I'm going to use this smaller end mill, but of course it's not going to reach past that clamp. So I'll just move this clamp, which luckily we don't really need anymore because now I can clamp it down between the crosshead slides. I'll put some brass on there to protect the surfaces. And now we'll be able to reach in here with this normally proportioned end mill. So I'm going to clean up that surface of that gland plate there, whatever you call that surface where the gland nut for the piston rod attaches. So I'm going to do it in a couple of passes here since my cutting area on this end mill is not very tall.
New in the Blondihacks store, stainless steel insulated beverage tooling. Extremely repeatable, compatible with metric and imperial beverages, also good for storing cutting oil.
Okay, so that surface is cleaned up, nothing is dimensioned yet, but now we can get an idea how that gland nut's going to fit in there, and you can see that I'm going to have to remove this kind of webbing area down there below that surface. And we still have quite a bit of material to come out of there that is necessary to form the gap. So I'm going to machine my way down to get rid of that webbing. And you can see I'm left with some kind of hooks there on the edges. I didn't want to risk getting into the crosshead area there, so I'll clean that up with a file later. Now, we need to leave enough material on the end of the casting for this 375 dimension that's going to eventually be there, while still creating the 250 dimension here. So I'm going to machine just enough off the ends of the crosshead slides here to square them up. So I'm once again kind of splitting the difference, machining just enough off the ends of those crosshead slides to clean them up, while also kind of trying to land on the dimension. And looks like we've got it. That's a 1/4 inch end mill there, so that fits in there perfectly. And we've still got plenty of material here on the end of the casting to create that 375 dimension. So I think we're in good shape. And you can see I've ended up with kind of a flat rectangle machined there in the bottom of that trench area. And the drawing didn't specifically call for that area to be finished, but I made the conscious decision to do that just because I thought it would be easier to do the other operations if I did that. And I thought it might look nice and, did my best to make it symmetrical. I want to double check I didn't remove too much off the end of that crosshead slide because the bolt holes are located from that gland plate surface. So a distance off there for one bolt hole and then a distance from that hole to the other one. And if I did my job right, that other hole should land a certain distance from that end of the slide plate, and it does. So we are good to go. If I'd machined too much off the end of that plate, it would have pushed the other bolt hole off the end of the plate, and that would have been bad. Okay, clean up our toys, and things are looking good so far. I think we're ready for the next step. Now, gentle viewer, let's discuss angled bearing surfaces. Join me, won't you?
So let's talk tactics again. Now, because I need to mill this at, says 45 degrees, I need to somehow stand it up in the mill, probably, so that I can do that operation. And this could be a little tricky because of the shape of the casting. Now, the good news is this angle doesn't have to be insanely precise. I mean, this is just a model. This 45-degree angle here is probably important on the real thing, but here on the model, it's mostly decorative. I don't know a lot about steam engineering, but my impression is that they angled the bearing caps at 45 degrees so that the forces from the piston are not pushing entirely in shear or entirely in stretch on the bolts on the bearing caps. So this kind of shares the forces in both of those dimensions. So, it's more important that they be the same rather than they be exactly 45 degrees. So we're not going to have to bust out the sine plate or sine bar or sine vise or various other fancy and very expensive ways that we could do this. However, this part is also probably too large for angle blocks, so a basic hobbyist setup like that is probably not going to work here. A great tool for this would be one of those angle adjustable machining plates that you can buy. Those are a lot cheaper than sine plates, sine vices, and other high precision angle fixtures. So that would be a great thing to have here. I don't happen to have one. So there's two different ways that we could do this, right? We could fixture it like this and mill it flat across the tops, or we could fixture it like this and side mill it. These both have pros and cons. Fixturing it like this is probably more difficult because of the height, but end milling that is going to be easier and give a nicer result. Trying to do it like this with a side milling operation, that's a very tall side mill, so I'd probably have to use a very long end mill, which isn't very rigid, and the results might not be as good. So not being in possession of any of the proper tools for doing this, some sort of angle adjustable fixture plate, we are left with the low budget hobbyist options. So here's what I've come up with. What I'm going to do is I'm going to fixture the casting onto a 1-2-3 block like so, and I'm going to take advantage of the height of my vise. And I'm going to clamp it in the vise at a 45-degree angle, clamp the 1-2-3 block, and the 1-2-3 block will be set with angle blocks in the vise. And if I need to, I can slide this up here, fixture it like that. And if I take light enough cuts, this stick out up here shouldn't be too big a problem for rigidity. And I don't have to take a lot of material off here. In fact, I'm trying to take as little as I can because I just want to face these off without pushing the surfaces too far inwards. Because if I push these surfaces too far down, I'm going to lose my crankshaft axis that I so carefully worked out earlier. Now the trick here is going to be getting these surfaces square to these ones that we machined earlier. Now I can't indicate on these because they're too small. However, these surfaces were milled in the same setup as these surfaces, so we know that they are parallel. So what I should be able to do is fixture this on the block, square the block to the mill, indicate on these nice long surfaces, tap this guy in until it's square or until it's parallel to the sides of the block, then bolt it down. Then when I go and put it in the vise, the angle blocks are setting this orientation, and that previous squaring with the block has set this orientation. So the end result should be surfaces that are at the right angle, coplanar with each other, and at right angles to these inside surfaces. Okay, so I'm going to clamp the 1, 2, 3 block in the vise because that's just going to automatically square it up to the mill. Oh, and did I mention I reinstalled the vise? Yeah, I reinstalled the vise. Now we can mount the casting on the 1, 2, 3 block and clamp it down in a convenient place and kind of roughly square it up, get us in the woodworker ballpark there. And snug that guy down, and now I'm indicating on the y-axis with the machined sides of the crosshead slides because again it's the longest machined surface that we have that's on the center axis of the engine, and I'm just tapping this guy in to get that guy running nice and parallel to the y-axis and by extension square to the block that it's mounted on. And now we can bring in the angle blocks. So I've got a 30-degree block and a 15-degree block, which if my university education paid for itself, should give us 45 degrees. Now the one thing I don't like about this setup is the orientation of the casting is depending entirely on a single bolt, and it would be very easy for it to hinge a little bit left to right. So I clamped some 1, 2, 3 blocks on the base there on either side of the casting, kind of just touching it to keep the bottom from swinging around and throwing the top surfaces out of whack. Once again, I'm mapping the surface with an indicator here before we make any cuts, and this landing is all within a couple of thousandths, so that's super encouraging. And if we skip over to the other landing now, the interesting thing here is that this landing is also pretty coplanar, but is all about 10 thou higher. So this could just be a difference in the casting, or it might mean that our part is crooked. So unfortunately, it's difficult to indicate now that we have it at a funny angle, but I can indicate in a couple of places at the top and bottom, and sure enough, we are about 2 thou off there. So I tapped that guy in, got it parallel again, double check my lands, and now one of them is about 8 thou off from the other, so I think it's just mostly casting variation, but I think we can be pretty confident now and do our machining. So I did a 10 thou pass on both lands, which as predicted really only touched the first one there. And then the second 10 thou pass cleaned up both of them. And a little customary deburring there, and that's looking good. I really like the way that the machined surfaces met up there in a nice corner. That's what I was hoping would happen. That's looking really good. You can see how our bearing cap will go on there once we've machined that. I think that's going to work out really well. I'm pretty excited. It's always a little bit bittersweet to tear down a hard-earned setup like this, but after triple and quadruple checking that there's no other operation I need to do from this position, I tore it all down, and it's looking really good. And that is all the time we have for today, so we will do more machining on this base casting next time. Thank you very much for watching, and I'll see you next time.